Hello, my amazing math students. This is Mrs. A, and I love math. And tonight we're looking at lesson 86, which is division of polynomials. The first ones we're going to start with is division of a polynomial by monomials, which is the easiest division we can do. But then we will go a little bit more difficult by the time we get to the end of the section. So we're going to start with the easiest one. And when we're dividing by a monomial, which means we only have one term in the divisor, it's very simple. Because we're going to take this polynomial and we're going to put each and every term over the divisor. So we're going to rewrite this as 3x cubed divided by x plus 7x squared divided by x minus x over x. So basically we're dividing each term by the monomial because the whole problem, the whole polynomial divided by the monomial is the same as each individual term divided by the monomial. So now we simplify. 3x cubed divided by x is 3x squared. And 7x squared divided by x is 7x. And negative x divided by x is negative 1. And that is pretty simple, isn't it? That's our answer. So this is example 2. We're going to divide this long polynomial by one term, 4x to the 4th. Remember, terms, a term is not separated by a plus or a minus sign. This is all a product with an exponent. That's one term. So now, since it's a monomial divisor, all we do is take 1, 2, 3 terms and put them over the 4x to the 4th. So 12x to the 12th divided by 4x to the 4th minus 8x to the 8th over 4x to the 4th plus, remember, I'm just keeping the sign, 4x to the 6th divided by 4x to the 4 equals. So now that I've written each term over the divisor, I simplify. 12 divided by 4 is 3, and x to the 12th divided by x to the 4th. Remember, when I divide, I subtract the exponents. I'm dividing like bases. I subtract the exponents. So that's going to be 3x to the 8th minus, since I'm dividing by positive, I just keep this sign, 2, and 8 minus 4 is 4, so x to the 4th, plus 1, x squared, and if I didn't want to, I wouldn't have to have the 1 there. Ones are optional, aren't they? I can put them there, or I don't have to have them in there because they're understood. So 3x to the 8th minus 2x to the 4th plus x squared. So those are so simple. We're going to move on to the more difficult ones now. Next, we're going to step it up a little bit. Division of polynomials by a binomial. Okay, so a binomial is 2 terms. In order to do this, I'm going to first review with just a plain division problem. So let's do something like 263 divided by 31. I'm just pulling these numbers out of my head because we're just reviewing basic division. Remember, when we're dividing, we take this number and we go into the first number it would go into. So 31 does not go into 2, so I'm going to try that. 31 does not go into 26, so I'm going to use all 3 of them. 31 does go into 263. About how many times? Now, to estimate, I can take the first one here and go into the first 2. So basically, I'm lopping off the 1 and the 3 for estimation purposes. About how many times does 3 go into 26? Well, let's try 8. So we're going to come over here and put an 8 right there. And 8 times 1 is 8. And 8 times 3 is 24. Get rid of this one right here. That wasn't supposed to be there. Now, what's the next step? I subtract, don't I? So I subtract, and 3 minus 8 doesn't work. So I come over here and make that a 5, bring that over 13 minus 8 is 5. 5 minus 4 is 1. And nothing over there, so 15 remainder. Now I'm out of terms, so if I don't want a decimal, and in this case I don't, I'm going to take this and put it over the divisor, and that will be my remainder, my fractional remainder. So 15 31st, okay, will be my answer. So 8 and 15 31st is how many times 31 would go into 263. Now let's talk about this a minute. First, we divide, then we multiply, we subtract, we compare, we bring down. So these are basic steps of division, and I wanted to go over them because they work for polynomials too. So we divide first, put an answer up there, then we take that answer and multiply it so that we can, what, subtract? And then we always compare. Now this is often done kind of automatically in our head, but it's important to look at it. 15 is less than 31. And that's the way it's supposed to be. So I'm always looking, did I take enough out? 15 is less than 31, so everything's good. And then I bring down the next one if I have more. And then I start back over again. So divide, multiply, subtract, compare, bring down. And I would keep on doing that process throughout the whole division. That's what we're going to do. The same thing with our polynomial division. Okay, so we're going to start off with negative 2x squared plus 3x cubed plus 5x plus 50 divided by negative 3 plus x. Now, I am not sure why they started out with this, but it is a good illustration of our very first rule. When we are dividing a polynomial by a binomial or another polynomial, we always want to make sure that our terms are in the right order. And this is what we call the descending order of the variable. We always want to find our highest agreed term and write it first, and then our next one, and then our next one, until we're done. We also want these to be in descending order of the variable. So we're going to rewrite this. We're going to say, okay, this is the same as 3x cubed should go first, and then I need an x squared term next. They should always go in order and not have any holes. So negative 2x squared. Then I have an x to the 1 term, 5x, and then I have a constant. The same thing goes for over here. I'm going to put my x first minus my 3. Now I'm ready to divide because all of my terms are in descending order with no holes. So now that I've got that done, we're going to erase this part up here at the top, and I'm going to put our little reminders up here. And our reminders are divide, multiply, subtract, compare, bring down. So let's put those up there. I'm going to go ahead and get rid of all of this so that we have plenty of room to work. Okay, so we're going to write divide, multiply, subtract, compare, bring down. The processes are not exactly like they are in regular division, but they're very close. So if you will keep those in front of you, you will hopefully not make any errors. Now, when we're dividing with a polynomial, it's a little bit easier than normal division because we always take just the first term into just the first term. We don't worry about the rest of the terms, not on the division step. Okay, so how many times does x go into 3x cubed? Well, Mrs. A is just a little bit dyslexic and had a little bit of a hard time when I was younger with this type of thing. I would actually have to say 3x cubed over x. I would have to write it like that. I don't have to do that anymore, but if you do need to do that, that's okay. Write 3x cubed divided by x. and then say, oh, okay, this is an x to the 1, so 3 minus 1 is 2, so the answer is 3x squared. Now, 3x squared is going to go above the x squared term down here. So we're going to do everything in columns, the cubes, the squares, the x to the 1, the constants. So since my answer is 3x squared, it's going to go right above here, 3x squared. Whew. Now all I've done was divide. Now I've got to multiply. Okay, so multiply. Now when I multiply by both of them. When I do the division, I just take the first one into the first one, but when I multiply, I use them both. 3x squared times a negative 3 will be a negative 9x squared. And yes, it's going to go underneath the x squared column. So negative 9x squared. And then 3x squared times x is 3x cubed. I need to erase that. 3x cubed. Now, I'm subtracting, and to subtract with polynomials, we change both signs and add. Subtraction is change both signs and add. Okay, so we're going to, there's my compare step. And that should always go out because when we divided, we just did this one into this one. We should always get it back. So our compare step is kind of a duh, it should always work, right? So this one should always go out. Now, negative 2x squared plus 9x squared is 7x squared. Okay, now we are there. We look at this one here, and basically this one is going to, we already did our compare step, we already going to bring down. So we subtracted and we compare, we're going to, this is our compare step right there. We're going to bring down. So we're going to bring down a plus 5x. Okay, so now the first one into the first one. We're starting right back over here with divide again. First one into the first one. 7x squared divided by x is 7x. So the 7x goes right above the x house. 7x, I divide with only one of them, but I multiply by both of these. Okay, so 7x times a negative 3 is a negative 21x. And a 7x times an x is a 7x squared. But I'm subtracting, so I must change both signs and add. See if I can get a little line there. Okay, so this one goes out. That's my compare step. And then I have 5x plus 21x is 26x. All right, so I need to get a little continuation paper here going. Let's see if I can hold this still enough. So this one goes out, and we get a 26x. Now, I'm going to bring down the last one, which is a plus 50. Okay, so now x goes into 26x how many times? Plus 26 times. 26 times a negative 3, oh my goodness, that's a big number. 6 times 3 is 18. 2 times 6 is 6, 78. 26 times x is 26x. And the sign in between is a negative because it was a 26 times a negative 3. So that's a negative 78. But remember that we're subtracting. Divide, multiply, subtract. When we're subtracting, subtraction is addition of the opposite. So I change both of the signs. And then this goes out. That's my check. And then 50 plus 78 is 128. Now, I'm all out of things to bring down, but I have 128 as my remainder. So I'm going to take my remainder and put it over x minus 3. So my whole answer is, let's see if I can duck down a little bit so you can see that. Okay, 3x squared plus 7x plus 26, And then at the very bottom of it all, at the end of it all, 128 over x minus 3. That was a pretty big problem. So in the book, it's a little bit neater, to say the least. And there is the final answer written all out in the correct form. So I wanted you to see it a little bit neater, but that's exactly what I had on the board, and I thought you might be able to follow it. So it's all in your book, but I wanted to show you it's really not any harder than normal division. You just kind of have to get used to divide, multiply, subtract, compare, bring down. Okay, so here we have a second example. And notice they did it again. We got to do some house cleaning here because they have a cube and then an x to the 1 and then an x to the 2 and then a constant. And over here they have a constant before the x. We have to put it in descending order of the variable. So we're going to change all of this to 2x cubed minus x squared minus x plus 4. It becomes so much easier. And then down here, we'll put x minus 2 in the divisor. We'll get rid of all that other gobbledygook that was written in the wrong order before we begin. And that's where we can put our quotient when we're done, is up there. So now that we have put it in the right order, which is the very first step, we're going to divide, multiply, subtract, compare, bring down. Remember, the division step is just the first one into the first one. 2x cubed divided by x is 2x squared. And it goes right above the x squared house, 2x squared. Now we multiply. 2x squared times both of these. So 2x squared times a negative 2 is a negative 4x squared. And yes, it goes in the x squared column. Negative 4x squared. 2x squared times x is 2x cubed, and it goes in the x cubed column. I'm subtracting, so I change both signs and add. Okay, so subtraction is addition of the opposite. So now there's my check step. It should always happen, right? Negative x squared plus 4x squared is 3x squared. And now it's time to bring down my negative x and start all over again. The first into the first, 3x squared divided by x is 3x. And 3x will go right up here above the x column, 3x. 3x times a negative 2 is a negative 6x. And it goes in the x column. 3x times x is 3x squared. And it goes right here in the x squared column. And now, let's get rid of that. I'm subtracting, so I change both signs and add. This cancels, as it always should. Negative x plus 6x is 5x. And I bring down the 4. Plus 4. X into 5x goes 5 times. 5 times a negative 2 is a negative 10. 5 times an x is a 5x. I'm subtracting, so I change both signs and add. This goes out, as it should. 10 plus 4 is 14. Nothing else to bring down, so now I write my remainder. My remainder will be 14 over my divisor of x minus 2. So my final answer should be 2x squared plus 3x plus 5 plus 14 over x minus 2. And then I'm going to show you in the book too. Okay, there's their division, which is always much neater than mine. And there's the answer, which is exactly what my answer was. All right, so this one is introducing something a little bit new. What do you do if you don't have one of each type of variable in your descending order of the variables? And the answer is you put in a dummy variable. All right, so let's check. So here we have 3x cubed. That's our highest one. So we're going to rearrange all of these in descending order of the variable. So 3x cubed. But I don't have an x squared, which is going to make it really nasty to keep all my columns in a row, in a column. So we're going to say plus 0x squared. It's as easy as that. Just make up a term, 0x squared. It doesn't have any value, but it holds a spot, which is going to be very nice for keeping your columns in order. And then I'm going to put the negative 2x. And then I'm going to put the plus 5. And as a divisor, I'm going to put x first, minus 3. Okay, so now I'm going to get rid of all that stuff on the top and use that as the spot where I'm going to put my quotient as I divide. And here we go. First goes into first. 3x cubed divided by x is 3x squared. We put it in over the x squared column, which we provided. So 3x squared. Now I multiply. 3x squared times a negative 3 is a negative 9x squared. I needed this dummy column again, didn't I? I needed an x squared spot. 3x squared times x is 3x cubed. Okay, so now we're subtracting. So I change both signs and add. This should always cancel. 0x squared plus 9x squared is 9x squared. I bring down my negative 2x. X goes into 9x squared, the first one into the first one, remember? And we're going to have 9x. So that's convenient. Here's my x column. It needs something over it. 9x. 9x times a negative 3 is negative 27x. 9x times an x is a 9x squared. I'm subtracting. So I change both signs and add. So now this should always go out. And it does. 27x minus 2x is 25x plus 5. Now, because I just brought this one down, I go again. X into 25x goes 25 times, so plus 25. Almost out of room on my board. 25 times a negative 3 is a negative 75. 25 times an x is a 25x. I'm subtracting, so I change both signs. This cancels. 75 plus 5 is 80. Okay, so now I have nothing else to bring down. So 80 is going to go over x minus 3 in my as my remainder. So my whole answer is 3x squared plus 9x plus 25 plus 80 over x minus 3. And let's see it in the book because it's much neater there. And here we are in the book so that you can see the problem. And you can see how they also, right here, inserted the 0x squared. We note that the dividend has an x cubed term and an x term, but no x squared term. A good ploy to avoid confusion is to insert an x squared term with 0 as its coefficient, which is exactly what we did, which gave us a place to put all of our x squareds. There was our final answer. Here is our last example problem. Almost forgot what they were called. Our last example problem, and then we're going to do our practices. Okay, now look at what they gave us. It's almost like they're just trying to confuse us. But we're not going to be confused, are we? We're going to put our x cubed in the front. We're going to notice that we have a negative 4, but it should be way at the end. So we're going to go down with dummy variables to fill in the holes. So plus 0x squared plus 0x, and then the minus 4 at the end. And then here we're going to just divide by x minus 3. And we're going to erase what we had there to make room for our quotient. And we have everything set up to divide. Okay, so divide, multiply, subtract, compare, bring down. So we're going to put first into first. That's minus right there. And x into x cubed is x squared times. So we're going to put x squared, but that's not a 0x squared. That's really a 1x squared. 1x squared times a negative 3 is a negative 3x squared. 1x squared times an x is an x cubed. I'm subtracting, so I change both signs and add. This goes out, as it always should. 0x squared plus 3x squared is 3x squared. I bring down my 0x. X goes into 3x squared 3x times. I put it right above the x column. 3x times a negative 3 is a negative 9x. 3x times an x is a 3x squared. I'm subtracting, so I change both signs. This one cancels. And then I have a 9x. Lastly, I bring down my negative 4. X goes into 9x 9 times. 9 times a negative 3 is, let's see if I raise this up a little bit. 9 times a negative 3 is a negative 27. 9 times an x is a 9x. I'm subtracting, so I change both signs and I add. This one goes out. 27 take away 4 is 23. So now my remainder on the end of all of this is going to be 23 over x minus 3. So x squared plus 3x plus 9 plus 23 over x minus 3. And I'll show you the final answer in the book. And there you have the last problem. Notice how they're setting it up the same way I did with 0x squared and 0x as their little dummy terms to take the place and hold the spot. And the answer is below. All right, so this is the first practice problem. Copy it down and then pause your video. Notice that this one is one of the easy ones. We're only dividing by a monomial, one term, which means we're going to take this x and put it under each term. So that's going to be 5x cubed divided by x minus 9x squared divided by x plus x divided by x. And then our final answer, 5x cubed over x is 5x squared, minus 9x squared over x is 9x, plus x over x is 1, and that's all there is to it. All right, this is example or practice problem number 2, and you should pause your video and go, after you copy it, go do it by yourself. See if you can remember all the steps. Okay, remember the first step is to get everything in descending order of the variable. So we're going to rewrite this, and we're going to have to rewrite this too. So the highest degree term is 6x cubed minus 3x squared plus the x minus the constant 40. And divide that by, I don't need that little hook. That's the square root, isn't it? So then that's going to be x minus 2 over here. All right, so now we're going to erase everything else. So we have room to work, and everything is now in the right order so that we have a column for everything. Okay, so now x goes into 6x cubed, 6x squared times 6x squared goes above the x squared column. Now we multiply. Divide, multiply, subtract, compare, bring down. 6x squared times a negative 2 is a negative 12x squared. 6x squared times an x is a 6x cubed. But I'm subtracting, so I change both signs and add. There's my compare. And then 12 and a negative 3 is 9x squared. Bring down the next term plus x. First into first. X into 9x squared goes 9x times. Put it above the x column. 9x times a negative 2 is a negative 18x. 9x times x is 9x squared. I'm subtracting, so I'm going to change both signs. And now this goes out. 18x plus x is 19x. Minus 40 is going to be x into 19x is positive 19 times. 19 times a negative 2 is a negative 38. 19 times x is a 19x minus plus, changing those signs, and I get a negative 2. Okay, so negative 2 will be my remainder over x minus 2. So let's think about what is our whole answer. Our whole answer is 6x squared plus 9x plus 19. And then at the end, minus 2 over x minus 2 is the remainder. Did you get it right? Okay, now on the last problem, this was the final answer. Now this minus can be out front like this. It could be up on top with a plus in the front. We'll just leave it like it is right there. Now, what if you get to the end of the problem and you go, is that right? Did I do it right or did I make a mistake? Especially on a test. This is my answer. Now remember, my divisor for that problem was x minus 2. Now, if I multiply, shouldn't I get back to my original? Now I've got my original down here on my leg. So I'm going to, as soon as I do this one, I'm going to show you the original and see if I got back to the original polynomial. So now, there's a little trick to this when you're multiplying. When you're multiplying this last term here, do it all together. In other words, this is 2 over x minus 2, but we're going to multiply by the whole x minus 2 instead of take it in parts and multiply by the negative 2 and then multiply by the x. Now the rest of it will multiply by each part individually, but for this last divisor, this last fractional remainder, we're just going to take x minus 2 and multiply it by negative 2 over x minus 2. And guess what my answer is? Negative 2. The x minus 2 on the bottom and the x minus 2 we're multiplying by cancel out. And I'm left with a negative 2. So I'm just going to put negative 2 over here. Okay, that way I don't have to remember it. And now I'm done with that one. Toss it. And I'm going to multiply everything else to see if I get back my original answer. 19 times the negative 2 is a negative 38. Okay. 9x times a negative 2 is a negative 18x. 6x squared times a negative 2 is a negative 12x squared. So now I'm done with the negative 2. I've multiplied everything by the negative 2. So now 19 times x is 19x. Now I'm going to put it in the x column. 19x. 9x times x is 9x squared. And 6x squared times x is 6x cubed. So now, let's put it all together and see if we get back to our original polynomial. So, here we go. 6x cubed has nothing to add to. Negative 12x squared and a 9x squared is a negative 3x squared. And then a negative 18x and a positive 19x is a positive x minus a 40. And that should have been my original polynomial. Did I get it right? Remember, this was my original division problem. And I got back my dividend. Remember, this under here was my dividend. This was my divisor. This was my quotient. Then at the end, to check it, I multiplied my quotient, which had a remainder down here. Remember the remainder. I multiplied my quotient by the divisor, and I got back the dividend that I started with. And they match. So just as it is when we're doing regular division and multiplication, we can check division by multiplication and vice versa. All right, we're getting close to the end of the lesson. We've got this one and one more problem, and then we'll call it quits. This one is so close to being right, but if we don't take care of it, we're going to have awful lot of trouble, okay? So we got x cubed, and then we jump all the way to a -5. So we're going to say x cubed plus 0x squared plus 0x, and then -5. That'll be my divisor, my dividend, and then x minus 2 is in the right order already. So I will erase all that. And here we go. X into x squared cubed goes x squared times. X squared times a -2 is a -2x squared. X squared times an x is an x cubed. I'm subtracting, so I change both signs and add. This goes out. That's my check step. And then this one is a 2x squared. I'm going to bring down my plus 0x. X goes into 2x squared, 2x times. 2x times a -2 is a -4x. 2x times an x is a 2x squared. I'm subtracting, so I change both signs and add. Now, this goes out. I'm left with a 4x. I bring down my -5. So now I'm going to say x goes into 4x 4 times. So I put a plus 4. 4 times a -2 is a -8. 4 times an x is a 4x. I'm subtracting, so I change both signs. This cancels. And I end up with a 3 as my remainder. So my fractional remainder will be 3 over x minus 2. So when I write it all out, it's going to be x squared plus 2x plus 4 plus 3 over x minus 2 as my remainder. So that's my answer. But again, shouldn't I be able to multiply this by this and get this back again if I did it right? Okay, this time for my check, I wrote it horizontally instead of vertically. We can do it both ways. But now it might be a little bit easier for you to see how this denominator and this, which is in the numerator, will cancel each other out. So we're just going to do this one first, and then we're just going to mark it off and be done with it. So we're going to multiply 3 over x minus 2 times the whole, what used to be the divisor, but now is the multiplier. So we're going to divide and we multiply, and this x minus 2 and that x minus 2 are going to cancel, leaving me just with a 3. So I'm going to write down the 3. I'm going to cancel that out as done. So now I'm going to distribute. Okay, I'm going to use the rest of these and multiply by the -2. I'm going to do all the rest of these and multiply by the x. So I'm going to distribute it now that I've got this troublesome little remainder done. So let's do everything by the -2 first. So 4 times the -2 is a -8. 2x times the -2 is a -4x. X squared times the -2 is a -2x squared. So now I've done the -2 by everything. Now I'm going to do the x by everything. So 4 times x is 4x, so we'll put it right there. 2x times x is 2x squared. X squared times x is x cubed. Now look what's happening. Remember, this was a plus down there. Do you see what happened? My -4x and my positive 4x cancel. My -2x squared, my positive 2x squared cancel. And I'm left with x cubed minus 8 plus 3 is a -5. And what was my original divisor? X cubed minus 5. And then x cubed minus 5. And I had to put all those dummy variables in. Checking by multiplication let you know that you got your problem right. And it's not that hard to do. We are on our last practice. This has been a long lesson. It's been a fun lesson, though. I really enjoy long division. But we're almost done. And we're going to remember that we are missing an x squared term. So I'm going to rewrite this. 3x cubed plus 0x squared minus 5x plus 4. Plus 4 almost fell off, didn't it? And then x minus 4 over here. So we're going to erase everything on the top one more time and have everything in our correct form to begin the long division. Now this is your practice. I really want you to go off and do it by yourself and then come back and check and see if you got the right answer. Okay, here we go. First into first. 3x cubed divided by x goes 3x squared. Above the x squared spot. 3x squared times a negative 4 is a negative 12x squared. 3x squared times x is a 3x cubed. I'm subtracting, so I change both signs and I add. This goes out. I get a 12x squared minus 5x comes down. X into 12x squared goes 12x times above the x house, the x column. 12x times a negative 4 is a negative 48x. 12x times an x is a 12x squared. I'm subtracting, so I change both signs and I add. This goes out. 48 take away 5 is 43x. Roaring down the last little 4 plus 4. X into 43x goes 43 times. 43 times the negative 4. Wow, that's a big number. 43 times the negative 4 looks like it would have a 12. And a 4 times 4 is 16. With one more is 17. And that is a negative. And then 43 times x is a 43x. I'm subtracting, so I change both signs. The 43x and the negative 43x cancel. The 4 and the 172 becomes a 176, which I'm then going to replace over my divisor. So my total answer is 3x squared plus 12x plus 43 over 176, plus 176 over x minus 4. And I'm going to write that out in one nice long stream right here. 3x squared plus 12x plus 43. And then the fractional portion here, try to get the light off the board, plus 176 over x minus 4 should be your last answer. And I am done. And you are ready to go do your homework. And this is Mrs. A. And may God bless your day.